Thank you everyone for being here today. My name is Courtney Jallo. I'm the Associate Director of Cures. We're also joined here today with Inge Bisconer and Jim Anshutz. They are the creators and the minds behind this program. They both have many years of experience working in the irrigation industry. Jim has used this program himself for many years in different formats. This is the first time it's come together in a really cohesive system that others can use without having to hold on to all of them that Jim has floating in his head. They've now installed it into this software so people can input the details and the software will provide answers for you. Inge is also a very experienced person in the irrigation industry. She was previously the president of the Irrigation Association. Last year, she received her Industry Achievement Award and was inducted in the Green Industry Hall of Fame. And she's going to be talking about some of the background resources in the program that you'll see a little bit later. So I'll go ahead and turn it over to Jim.
This program is actually at the beginning in a process to assist growers to improve overall performance of their irrigation systems. We have several systems that are included in the program: drip micro, tape or thin wall dripper line, and under tree sprinklers. So there's 3 different routines in here and several routines within the routine to evaluate about 95% of those systems which are in the field right now. The intent of the program is to be able to collect minimal and sufficient amounts of data to calculate the distribution uniformity. In addition, while the evaluators in the field, they collect information on the performance of the system, which gives us a better idea of some of the things that the grower can attend to himself in order to improve the overall performance. The program is developed with a protocol that is embedded in the IRTC evaluation program. So we use all of the calculation protocol, but we minimize the amount of data in order to get an answer for the grower. How is your system performing? And based upon these inputs, can you afford to make an investment to improve your overall distribution uniformity? Do you have a problem? And can you afford to spend money to fix it? The next process is to do a full ITRC evaluation, which gathers more information to allow a designer to come up with an engineered upgrade in order to improve the overall system. So that's a step process. Do I have a problem? Can I afford to spend money? Present the cost to them and let the grower make a decision about if you'd like to make the investment. All right. So first off, there's 10 tabs across the top of the program. The first is basically a welcome screen, which walks through what the program is, who developed it, etc. Then there's a program guide. It explains in more detail how the program operates. And within this page, there is a full-blown user's manual. So there's a lot of detail in here that explains each and every one of the evaluations which are input into the program for you to look at from an example standpoint. You can then move over to the user manual and it will explain fully all of the inputs and the outputs, etc. So once you have an evaluation in there, you can go over to the user manual. It's a very detailed manual put together by Inge. This is the beginning of the program. This is where we enter the evaluation name. We also select the type of evaluation that we're going to input. So I'm going to talk about drip micro. One of the examples I have in here, and it's the simplest one, is a single drip line going one direction with pressure compensating emitters. Across the top, you can see here's a tab for creating a new evaluation. So if I open that, there'll be a blank screen there with the inputs that you need to provide. You can save the evaluation once you've input all the data. We have the opportunity to upload non-specific information for the state of California so that they can actually see some of the areas and crops in the state of California that are operating below an acceptable level. You can delete evaluations. And here's the print forms. I'm going to call that up. I'm just going to show one of the forms. This is a drip micro. It's the PC One Direction. All of the forms that you need to input the data to then move it to the program are in here. At the beginning of evaluation, You select the system that you have, you print off the forms, and it will give you guidance on how to and where to select the information. In addition, you can print the evaluation reports from here. I won't do that at this moment. That prints out all of the evaluation reports that you can then hand to the grower and walk him through to show him what it is you've done, what it is you found, and then to demonstrate to him that he does have an opportunity based upon his performance of the existing system to improve the distribution uniformity. It will translate things into dollars and cents so he can make a financial decision as to whether he wants to move forward in the process. If you have several evaluations in there for one grower, there is an aggregated report. I don't think this will take too long to show. Here I can choose a grower, and if I've done more than one system for him, it summarizes the basic output of what your savings are. So there is an individual report, which is about 10 or 11 pages. And then there is an opportunity to quickly look at the overall evaluations you've done for a particular grower. Okay, so I have the single drip line, one direction, pressure compensating emitter. The farm information tab is where the basic information on the system is input. You can input the pictures, graphs, whatever to identify the irrigation system here. You can either scroll down, because this is multiple screens, or you can select up here just the farm details, just the information on the emission device, or in the all, I can scroll down and you can see the basic information. See the owner, his location, his cell phone number, his email address. And these are all systems which Bill Williams is not real. It's systems that I put in here, which were evaluations that were done, but without the grower information. The manufacturer, what type of dripper line you have out there, what size it is, the spacing of the trees, and etc. So this is the basic information that we input in order to be able to do some of the calculations here. The next tab, you'll have a form if you print those forms off, which will look very much like this, so that you can go directly from the paper form to inputting the data into the computer program. If I hover over here, it'll provide you some guidance on, okay, relative to where the pump is, where do we suggest that you take your measurements? And what we're doing is we're taking one set and one lateral, a representative lateral within that set in order to calculate the distribution uniformity. We don't want the worst performing area. We don't want the best performing area. We want the average. How do you find the average? Typically, my experience is you deal with either the farm manager or the irrigator that knows the system. They know where they have the worst performance in the system and the best performance and where an average area is. So we take the evaluation from one PVC lateral with the hoses attached to it. In the pressure compensating, we collect both pressures and flows. In the calculation, we only use the flow information to calculate the distribution uniformity. Why is that? For a pressure compensating emitter, 99% of the problems in the field are from plugging. Pressure should not be an issue in the distribution uniformity as long as you have the minimum pressure requirement for that device in the field. So if I look at a pressure compensating device here, you see the lowest pressure out there is 10 psi. That's above the threshold for most products in the marketplace of around 7 psi. So pressure should have no impact on the distribution uniformity, only the flow rates that you collect. And that will be the indicated performance of the irrigation system because, again, most of the degradation is due to plugging. So we input that data. Again, looking back at here, this is the location to take it from. We then can calculate the distribution uniformity. This data is taken in milliliters. You can see over here, there's a very good explanation of exactly what you need to do collecting the data in the particular field. So a lot of things that are found in the manual are also within the input sheet. So if you have questions, you can go to the text You can go to the picture and make sure you get the information input correctly. So with that, we now can calculate the distribution uniformity. So this is over here. You saw that we collected all the data in milliliters, and also we collected the pressures. It's then translated into gallons per hour. And then the information above is graphically represented down here. So this emission device was supposed to produce this type of flow rate at pressures from 9 psi up to around 20. This graphical representation is something that always catches the grower's attention, because even though it's pressure compensated, it's supposed to be putting out the average amount, you can see the variation at different pressures out there. And in these examples, typically on the pressure compensated, this is all because of plugging in the field. But that's a lot of variation. And even when you calculate the distribution uniformity, which is 82%, which most growers would think, hey, that's excellent. That's well within some acceptable levels. But this is how much variation you have in the field. And this translates into growth of the plant out there. If you have that much variation, you're going to have an awful lot of variation in the development and the production of that crop that you have in the field. This top graph here shows that at 82%, if we're applying the amount of water that is required, most growers know, say they need 3 feet. So they put 3 feet of water out there, and they make the assumption that all the crop gets 3 feet of water. So that's the target, is in this example, 3.5 feet. But you can see, if you only put the amount of water on that is required in the field, you've under irrigated about 50% of the field. You've over irrigated about 50% of the field. So this is poorer production in yield and quality. This is poorer production in quality because of the excess water that you've applied, which drives all of the oxygen out of the soil. But you can see, if our target was 3.5, we're actually applying over 4 feet of water in this particular area. So over irrigated, under irrigated. What most growers do is they think that they need 3.5 feet of water. They'll continue to irrigate to try and apply water to this under irrigated area. If they do that, which most do, they continue to irrigate to the worst area in the field, you can see what happens. Now we have over 5 feet of water, not 3.5 that we need, applied to this particular area. So we over irrigate. So this is lost dollars provided to produce the energy, water, and also fertilizer. Now in each one of these tabs, there is a report up here. So this is an on-screen for the evaluator to look at it and see, do I have something that looks strange in here? Did I perhaps input the wrong number? And also to provide some visual to the grower of what happens when you under irrigate or you over irrigate. This is one section of the report which will be generated from that evaluations tab. So you can see it puts the information into a text format along with the graphics. So this is all the information put into a 2-page report, which demonstrates how well the system's actually operating from a distribution uniformity standpoint. So we collected pressures and flows. We calculated the distribution uniformity. But while we're in the field, there are other things that we want to collect. And some of this is used in the calculation of the economics. There's several grower questions we ask. Do you have a deep well? Has a pump been replaced? You can see in the upper left-hand corner, depending upon how you answer that question, it will actually give you an output. So here, if I say that there's a flow and pressure decreased recently, there's a note up here. It says reduction of flow is an indication that the pump is warm and or not operating properly. This information then shows up in the preview report. So not only do we provide them with a report on the distribution uniformity, we provide them with a report of all of the things that you answered in here there will be a statement to those particular inputs. So here is an overall assessment of the things that we found in the field that are not operating properly. And many of these things can be attended to by the grower. This talks about the frequency of system flushing. This one appears to be inadequate. They're not flushing it often enough or long enough, et cetera. So that's a report that will be generated from this tab. Also, we input the filter information. Has the sand been changed? The emission device, how much plugging do we find out there? Are there different types of irrigation devices in the field? Are there chemical buildup? And again, on the upper left, you can see I input yes. There is an output which will be produced from the report I shared with you just a moment ago. So it forces you to answer what you've observed in the field, what was plugging it, insects, soil particles, etc. And again, it will provide an output which you'll find in the report. So this is the grower questions and the observations that the evaluator makes in the field. Typically, you go out there and you take the measurements, you calculate the distribution uniformity, but this provides you with more information because you're forced to collect observations in the field and also gather some answers from growers about particular things of their system. So we looked at the DU measurements, we looked at the DU report, we looked at the grower questions. And again, over here, I can either scroll down or I can just choose. Just give me the screen with the grower questions. Just give me the screen with the evaluator in field. And again, when you print out the forms, there will be a form that you will collect this information from manually, and then you will input it into the program. In addition, while we're out there, we collect information on flow meters, the filters, what the pressure loss is across the filter system. Do you have control valves? What's the pressure upstream and downstream? And dependent upon the answers that we provide, it will then give you some output results. It will say, perhaps the loss that you have across the valve or the submain is too high. This will all be printed in the report. So again, there's a print report preview up here, and we can also print it now, or we can print it later when we print all of the reports. So meters, filters, valves, regulators, emission devices, information is collected in order to assess how well is it operating relative to how it should be operating. Inside the program, there is operating specifications for just about every type of device or piece of equipment which is found in the field. So this then says, here's how it's currently operating. It then matches it against that type of filter system and provides you with an output of, is it working like it is supposed to be working? A pump test is always extremely important. So if you have a pump test for the deep wells, the boosters, etc., you can input the information from a pump test. If not, you can put in the information which is in white, and it will calculate some of these other values and provide us with an estimate of how well the pump is operating. So this is a well pump with 75 horsepower. It's operating at 41% based upon very few pieces of input that you can collect while you're in the field, like the average cost of energy, standing water level, the discharge pressure on the gauge at the deep well, the measured flow rate, etc. And it will provide an estimate of how well the system's operating and also what the savings would be if you were to improve the pump performance. So this pump is operating at 41%. An optimized efficiency typically for a well is around 55. So if we were to make an investment, we would save $2,900 per year. On the right, there is a graphic which will show the grower. I'm going to jump back here just for a moment. We asked the grower what his desired return on investment is. Most growers have an idea. They make an investment, they want the return on an investment in 3 years, 2 years, 4 years, 5 years. That then generates that curve, which I'm going to go back to. The other important piece of information that if we improve your distribution uniformity, what type of increase do you think that you'll obtain in your yield? Now, the industry has a rule of thumb that says for every 1% of improvement in the distribution uniformity.
Jim, we lost the chart. Move the cursor over. Thank you. Keep it right there.
There's a chart here which provides you with guidance. So in the example, if you have a current distribution uniformity of 75% in yellow, and if you say, I think I'm going to receive about 0.5% for each improvement in distribution uniformity, that's a 7.5% improvement in your yield in the field. Now, this is not something which is calculatable. Again, the irrigation industry has a 1-to-1 as they use it as a rule of thumb. But this is a grower's input. No, I don't think I'll get 1% improvement. I think I'll get half, or I'll get 25%, or I'll get 75%. That's a grower input. I go back here to the pump improvement. So that grower desires to have a return on investment of 3 years. On the pump, we don't know how much it will cost in order to improve that performance, but it says to the grower, if your return on investment's 3 years, you can afford to spend over $8,000 of repair. So this provides him with some information to be able to go to his pump provider and say, I need to find out how much it would cost to improve the performance of my existing pump, bring that performance up to an optimized level. And then he can look to see how much he can afford to spend. So to make that improvement, he can afford to spend $8,000. If the pump repair is $6,000, then it's less than a 3-year return on investment. Here's the real nuts and bolts of the output from the program. The last tab here is talking about the distribution uniformity improvement. So his current system's operating at 82%. What we chose in the program is what's obtainable is if you were to make the necessary improvements in your system, you could return the operating condition to 90%. Now, in reality, we could improve the performance to 93 or 95, but this is a conservative estimate for the grower. If you were to make an investment to improve from 82 to 90, how much can I actually afford to spend? So this grower was using both surface water and also water at a rate of 50% of his surface water, which was input into the farm information tab, and 50% deep water. And then the booster actually pumps all the water to the field. So he had $100 an acre foot for water. There's almost an $81 per acre foot of energy that's necessary to bring the water up out of the ground. Then there's almost $75 per acre foot of cost to run his booster pump. That was calculated from numbers that were input previously, as I showed you on the pump improvements financial tab. So it pulls those numbers up and then provides us to calculate this financial information. We also collect from him the average yield. Most growers will supply that. If not, you could look up, if I hover over that, it shows you a resource to be able to obtain what the CDFA has as an average yield for this particular crop, which happens to be almonds. So you can click on there, go to the CDFA, and you can actually input a piece of information about the average yield if he's reluctant to share that. So all the information then is based upon that number that's put in on the average yield. The yield increase, in this particular example, we improve it by 8%, the distribution uniformity. He said he would expect to receive 0.5% for every percentage point. That little table comes up again. In my experience, Doesn't matter. 5% yield improvement in any crop that we grow here in California is a significant amount of money that you return to your operation because you have improved the performance of that system. Here we input the income per unit of yield. And there is another hover on there where you can go to, and it will give you average income per unit of yield for the crops in California. The spreadsheet down here, which is embedded, is a lot of information. The grower has selected a 3-year return on investment. Down here's the calculations. If I improve from 82 to 90, my surface water expense will be reduced by almost $20 per acre. My surface water energy costs will be reduced by about $14 per acre per year. The groundwater, the cost to pull the water out of the ground will be reduced by $30. The fertigation expense, which is up here, you can either include it or not. This grower was spending $250 an acre on fertilizer that was put through the irrigation system, which if you think back to that graph, you can see if you over irrigate, you lose the value of that fertilizer. So there is an opportunity to reduce your fertilizer application because you're reducing your water application by improving the distribution uniformity. Down at the bottom is the total. I have an opportunity to save $258 an acre per year if I am to make that investment to improve my distribution uniformity. Almost $26,000 on a 100-acre field. Here's the graphics over here. My desired return on investment is 3 years. My total savings in water, energy, and fertigation expenses, along with my increased yield opportunity, shows me that I can afford to spend almost $800 an acre and get that money back in 3 years. The next year, I'll just save $800. The next year, I'll just save $800. So this gives a grower a picture of the financial opportunity if he were to make an investment to increase the distribution uniformity from 82% to 90. Now, Inge's going to show you a graphic of all the systems that I've evaluated in the state of California. The median is 60 to 65%. Every time we do an evaluation and I see that 60 or 65%, I can't believe that the systems are operating so poorly, but they are. Most growers don't realize, and it happens over time. You start out with a well-designed system at 90 to 95%. You don't flush it as often as you should. You aren't treating the water with chemicals to keep the algae from growing. You have leaks in the field. You have multiple types of devices and on. The overall drip microsystem is operating at the median of the evaluations I've done at about 60 to 65%. So if I were to put 65% into an example, you can imagine what the economics would look like. It would go up around $1,500 an acre that he can actually afford to spend to improve his overall performance. So again, this is a bottom line to the grower. And then the other curves out here are for the individual components. There's the water and energy only, is almost $200. Yield improvement, which is a big one, is around $550 an acre of lost income opportunity due to the poor yield or the yield that he could obtain. And the fertilizer saving. This is something we all know is being very much focused on in the state of California, especially nitrates into the groundwater. And there is a lot of regulation and compliance that's being put in place. This is going to be something that people are going to focus on from here on out. And water and power has become extremely expensive. In some areas, water has become very limited. Just an 8% improvement in the distribution uniformity will save the grower, in this example, about $26,000 a year. I'm going to go back for just a moment to the print the evaluation reports. So now that I've done the evaluation, I can print the reports that you will supply to the grower. Inge's manual, there is a script, and it will provide you with guidance on how to deliver this report to the grower and the things to talk about and highlight that he actually needs to improve in order to get to that more effective use of his input costs. But I'm going to preview a report. This is a summary report. This was the last screen you saw. It talks about what your inputs were, what your system was, and what the potential savings are here. Let's go to just one more. This now talks about the equipment performance, how much money you can save, and it shows you a total of the economic opportunity here. One more. This is grower questions and the observations were made in the field. And I previewed that when we were actually on that tab. So dependent upon the information the grower gave us and the observations we made in the field, it talks about each one of those specific areas of his irrigation system, like the sand media filters. Based upon the information that we gathered, here's the output of what you most likely need to do to improve the performance of that piece of equipment in the field. It's not translated into the dollars, just the distribution uniformity is. But while we were in the field taking pressure and flow measurements, we took a lot of additional observations. So we provide more information to the grower. So you can see there's an example for each type of potential system out there that you'll find. And that was the drip micro. We have a routine for the tape with examples. And each one of these examples is found in the user's manual and it explains all of the outputs, all of the inputs, etc. It's a very long document, but you can hone in specifically on that particular example or any example that you want to look at here to let you better understand and to learn how to properly input the information and then how to properly share the information with the grower. With that, I thank you very much for your time. I know that is a fast run through, but we do have limited time here. One thing I noticed I forgot to mention is here on the evaluations page, here's where you register and log in. So you can create an account and the setup. You can always look to see if you have the most up-to-date program because we will be upgrading or adjusting things over time perhaps. So you can check to make sure that you have the latest program. With that, thank you very much for your time. I greatly appreciate that. And I'm going to turn it over to my partner here, Inge, and she'll talk a little bit more about the things behind what this program is intended to assist the grower with.